Hi, I'm Tom Field, Senior Vice President of Editorial with Information Security Media Group. I want to welcome you to today's session entitled Rise of the Machines, the State of Unmanaged and IoT Device Security. Your presenter today is Jeff Horne. He's the CISO with Ordr. Now, before I turn this over to Jeff, let me give you a little bit of background on today's session. Start with this. How many unmanaged and IoT devices are connected to your network today? How has this number and your visibility changed since you deployed a remote workforce? Do you have a shadow IoT problem? What are the top IoT device security issues that you should be aware of? In this webinar today, Jeff Horne is going to review key findings from a study of more than 5 million unmanaged and IoT devices in Ordr deployments across vertical industries. He discusses the top visibility and security issues found and outlines best practices to address them. Among the topics, security challenges with unmanaged and IoT devices, top security issues identified from vulnerabilities to VLAN and compliance violations, shadow IoT devices identified in the network, and security best practices to protect these devices without impacting business operations. Let me take just a moment to tell you about my organization, Information Security Media Group. We are a global education and intelligence firm. You might know us best by one of our more than 30+ international media sites. These include Bank Info Security for financial services, Gov Info Security for the public sector, and Healthcare Info Security for the medical community. We also publish Info Risk Today, Data Breach Today, and Careers Info Security. Every one of our sites is dedicated to providing education and news regarding information security, but specifically tailored to their individual sectors. With over 950,000 members registered to our sites, we've created a true information source that tackles the key issues of interest to our unique audience. Just a few notes of housekeeping, please. If you have any questions for Jeff during the course of this session, you can submit them anytime by the chat window on your screen. We may not be able to get to every question today, but for those that we can't answer in the course of this session, we will get responses back to you via email. Now, if any of you should experience technical issues while viewing today's webinar, you can dial the number you see on your screen now. If you dial extension 115, we do have technical support staff standing by to help. Also, I do need to emphasize, the content being presented in today's webinar is copyrighted material. As such, it's meant for today's session and individual study purposes only. If you or your organization would like to use any of the information presented today, or if you're looking for customized training materials, please contact us. My pleasure to introduce our sponsor today, Ordr. Ordr secures the millions of enterprise IoT and unmanaged devices, such as manufacturing machines, building systems, medical equipment, printers, and more that run within global networks. The Ordr Systems Control Engine uses machine learning to automatically discover and classify every IoT and unmanaged device, map all communications, detect and prioritize vulnerabilities, and then proactively secure each device through dynamic policy generation and segmentation. Organizations use Ordr to discover their devices, track usage, achieve proactive protection and compliance. And for more information about Ordr, you can visit ordr.net. Now, my pleasure to introduce our speaker today. Again, he's Jeff Horne. He's currently the CISO at Ordr, where he's responsible for security direction, both within Ordr products and internal security. Prior to coming to Ordr, Jeff was the VP of Information Security for Optiv, where he was responsible for all security operations, governance, risk, and compliance, endpoint, internal incident response, physical security, and employee security awareness groups. Prior to that, he was Senior Director of Information Security for SpaceX. With that, let me turn you over now to the more than capable hands of Jeff Horne. Jeff, it's all yours.
Thank you so much, Tom. As Tom mentioned, my name is Jeff Horne. I'm the Chief Security Officer at Ordr. At Ordr, we make a comprehensive platform to secure pretty much any device on the network, be it an IoT, OT, IOMT, managed and even unmanaged devices. Through our platform, we enable the entire device security workflow, and we address the needs of security networking and device owners in several different industries. As you can see here, we have wonderful partners and even more wonderful customers. Ordr currently has a little over 80 employees. We've raised $50 million in the last few months, and we have customers in North America, Europe, and Japan. As you can imagine, within the last year, we've seen an explosive growth in IoT and IoMT devices. In 2020, we expect there to be 4 billion connected people in the world. This space is going to have over 4 trillion in revenue opportunity. We've seen 20 million apps, 25 billion embedded intelligent systems, and we estimate that we're going to see around 50 trillion gigabytes of data transacted through these IoT, IoMT devices. You're probably all familiar with these things. The Mirai botnet and Dark Nexus. They targeted IoT devices with common exploits and things like weak default passwords like admin. You've also seen that researchers are looking at implantable devices from a health community perspective that are vulnerable to exploits that can be transmitted wirelessly over either Bluetooth or Wi-Fi. You've probably seen the news where hackers are breaking into security cameras or breaking into cameras at home using weak exploits or default username and passwords. One of the things that we see inside of enterprises is the predominance of televisions and smart TVs. These TVs usually run an embedded OS, usually based on Linux, and they're now coming with cameras and recording features like mics. And the FBI recently put out a warning that hackers could use exploits and vulnerabilities on these televisions in order to remotely connect, turn on the camera, turn on the microphone, and start recording conversations. And then last year, we actually saw a 300% rise in cyber attacks against IoT devices. So what makes these IoT devices, so targeted by these hackers? A lot of these device manufacturers are putting weak and guessable passwords inside of these devices. They have insecure network services. They're not deployed correctly. They're deployed right on the internet. Usually they have insecure services, insecure privacy protections, and a complete lack of device management. If left unchecked, these IoT devices just become extremely pervasive inside of the network. We estimate by 2023, the average CIO will be responsible for more than 3 times the endpoints that they managed in 2019. And this is largely due to the increase in IoT devices. These IoT devices are utilized by hackers in order to spread ransomware. And the global damages from ransomware reached about $11.5 billion in 2019. From a healthcare institution perspective, with these IoT devices now responsible for spreading malware, we're seeing that over 75% of the healthcare institutions are infected by malware on a yearly basis. By 2021, we estimate that 70% of OT security will be managed directly by the CIO or CISO or CSO departments, and that's up from 35% today. And then also we estimate that ransomware will attack a business every 14 seconds by the end of 2020. Many IoT devices are trivial to compromise and continue to be pervasive on the network. And you simply cannot protect what you cannot see. So, number one, visibility is key here for these IoT devices. One of the things that we found in the healthcare industry is that passive collection and identification of devices is preferred. Obviously, from both a security and IT perspective, maintaining a complete asset inventory is absolutely vital to network security. As these devices enter the network, you need to be able to immediately identify them and classify them. And you can't be dependent on a system being online or on the network at the time of scan. Traditional scanners just don't work, both from a time of scan and having to have the devices operating at the time. Or also, we're seeing that a lot of these sensitive IoT devices and IoMT devices simply can't handle a regular port scan from some of these scanners. They'll simply fall over or they'll crash. So we've discovered that passive collection and identification of devices is absolutely preferred across the industries. One other thing is absolutely vital to protecting IoT devices is continual monitoring. Being able to passively identify devices, classify them, and identify vulnerabilities is also key. Being able to look at their external communications from the devices and build a behavioral model of how these devices typically communicate allows you to detect things like behavioral anomalies. You obviously don't want your video camera suddenly communicating with China, for instance. And also, once you've classified and discovered these devices, creating a security-focused segmentation policy is absolutely key for these IoT devices, particularly if they cannot be patched for simple vulnerabilities. And as I said, behavior monitoring is absolutely key. If you're not continually monitoring your IoT devices, you are absolutely left vulnerable. So once you have total visibility, you can start answering really important questions. Things like, are you seeing your cameras communicate with anything strange or outside sites that are potentially malicious? Are you seeing any sort of unusual activities internally? A lot of these pieces of malware will scan for IoT devices in order to discover, both if they exist on the network, but also are they vulnerable to certain techniques? And being able to see that reconnaissance is absolutely key. Being able to answer things like, how many LG WebOS TVs do I have on my network? And how many are potentially vulnerable to turning on the camera and microphone system and recording remotely? Also, being able to have this type of visibility also extends to managed devices, like how many servers do you have? What are those operating systems that those servers are running? And then also, are any devices managed, unmanaged IoT devices? Are they connecting with any malicious websites? Some of the things that we've seen at Ordr are simple, like phishing attacks. Someone gets an email, they click on the link, and they accidentally visit a malicious website or a phishing website. And, that's a managed device that we've seen. But we've also seen complicated attacks. Things like rogue access points put in place in order to steal Wi-Fi credentials in enterprise environments. We've even seen a badge reader taken off of a door and replaced with a malicious badge reader that was connecting to the network that would allow unauthorized access. Similarly, we've seen, simple spoofing techniques. Once hackers break into environments, they're simply spoofing their MAC address to look like, a legitimate device in order to bypass access control lists. We've seen autonomous pieces of malware spread ransomware and also contribute to distributed denial of service attacks on IoT devices with weak username and passwords. Over the last year, Ordr's been conducting a case study across several industries from customers utilizing the Ordr platform. We've taken a look at over 5 million unmanaged IoT and IoMT devices from Ordr deployments across a variety of verticals, including healthcare, life sciences, retail, and manufacturing. This has all been aggregated into a report that's going to be released subsequently to this webinar called The Rise of the Machines. And let's go through some of the data that we discovered over the last year. Ordr has identified several IoT devices that should not be living alongside the standard network or the user network in terms of workstations and servers. Inside of retail, we saw 20% of the deployments had potential PCI violations where card readers were present on the core network alongside workstations, printers, servers, and users. Typically, these card readers are isolated from the network, or at least we recommend that these card readers are isolated from the network in order to protect, obviously, the cardholder data that's being passed through the network. Inside of healthcare deployments, we saw 75% of healthcare environments had medical devices alongside non-medical IoT devices inside the network. So you can imagine this being, we saw a infusion pump connected to a patient that is sitting on the same network as a workstation for a nurse or a vending machine in the guest lobby. Obviously these devices need to be segregated from the network either through a VLAN or through a subnet, just so they can communicate with like devices and protect these devices from some of the inherent vulnerabilities they contain. As I mentioned, Ordr identified several deployments with vulnerabilities and FDA recalls inside of healthcare. Unfortunately, these IoT device manufacturers are really lacking behind in the way of security development life cycles corresponding with their products. A lot of these IoT and IoMT devices are coming with completely unsupported operating systems. They're being deployed with weak, guessable, and hard-coded passwords, in some cases that can never be changed. They have insecure network services that have known vulnerabilities that cannot be patched. And they truly lack, in some ways, an update mechanism that is resilient enough in order to allow customers to update them regularly. In 86% of the healthcare deployments, we've seen more than 10 FDA recalls against their medical and IoT devices using the Ordr product. We also, as I mentioned, identified deployments with legacy unsupported operating systems. I can tell you from experience, looking at the medical devices and particularly large medical equipment, they're typically running things like Windows XP. And in our year case study, we discovered that between 15 and 19% of the medical devices run on operating systems like Windows 7 or older, things Windows XP, Windows CE, ME, and the 9X versions of Windows that are, of course, no longer supported. And this is really important because, obviously these systems have vulnerabilities, and vulnerabilities keep getting discovered, but patches are obviously never going to be made available. And in one of the instances inside of our case study, we saw one organization had 7,000 devices running vulnerable versions and unpatchable versions of Windows XP. During our case study, Ordr identified several devices that were just behaving badly. Things like IoT devices that were being suddenly used for Bitcoin mining. Things like cameras that were showing unusual patterns when they would suddenly connect to a command and control server in Russia or Iran. In one deployment, we saw a parking gate system that was infected with malware and distributing malware throughout the network. And then we also saw a proliferation of undocumented and previously unknown firewalls making outbound VPN connections. This one's most notable because during this COVID pandemic, we've seen several instances where employees are placing both VPNs and firewalls into internal networks to be able to enable a remote workforce or remote connection. And this becomes an incredibly difficult issue from a security perspective, trying to understand where all ingress and egress points are for your network. We also saw medical devices running YouTube and Facebook applications. And obviously, Facebook and YouTube should not be accessible from those medical devices. Ordr also identified several shadow IT devices within our network deployments. Things like 95% of the healthcare deployments that we saw had Amazon Echoes and Alexas active inside the environment where patients sit. So obviously this is not optimal from a HIPAA perspective, as these Amazon Echoes can record data which might include sensitive patient information. We also saw in these healthcare deployments things like Teslas showing up on the corporate network and Pelotons, an elevator control system in one case where the users were unaware that their elevator control system was actually connected to their network. So how can Ordr address these risks once we find them? Ordr's approach to the device security lifecycle really consists of discovering all of the devices, baselining all of the communications, analyzing the devices for any vulnerabilities, and then ultimately segmenting these devices through either a layer 2 VLAN or layer 3 subnet. First, when we discover devices, we're completely able to do this passively over the wire. So we're able to discover devices and then properly classify them down to the serial number and firmware without any agent and without any scans taking place on the network. Once we've discovered these devices, we're able to take a proper baseline, not only figuring out where these devices sit in the network, but also what do they regularly connect to. Once we've done the appropriate baselining, we then go into the analysis phase, which we figure out if these devices have any sort of vulnerabilities. Because we've classified them down to the serial number and firmware level, we're able to see if they have any sort of manufacturing or FDA recall data available to them. Additionally, we use deep packet inspection on the network to see if there's any exploits that are being transacted or if these devices are utilizing any weak ciphers. Once our analysis phase is over, we can build automated policies and recommend policies from a micro-segmentation perspective, and we can enforce these policies on NAC, firewalls, and switching cores. We can also segment from an incident response perspective. So considering, some of these devices could be spreading malware on the network, we can suggest and implement and enforce immediate emergency segmentation policies from both a subnet and VLAN perspective, allowing these devices to be removed from the network and then remediated by whatever tools available. At Ordr, we use artificial intelligence and machine learning in order to not only classify but baseline IoT devices on the network. Fortunately, a lot of IoT devices, their connections are very deterministic. So artificial intelligence and machine learning are incredibly applicable in this situation. Utilizing artificial intelligence and machine learning, we're able to discover and classify all of the devices in the network, and then subsequently learn their communication behaviors and how they interact with the environment. Once we have this, we can map and baseline all of those communications and build context for both an IT management and security context within the environment. And then ultimately, like I mentioned, we can create segmentation policies based off of these behaviors and communications and enforce those policies from any of the network switches, NAC implementations, or firewalls you may have. During Ordr's classification, we obviously capture things like operating system version when analyzing devices. And this allows you to do things like searching for legacy operating systems in your environment. In this case, you can see that there is a MRI machine that's running Windows XP. And obviously, we would recommend a segmentation policy that makes sure that this device is isolated on a network where external communications are prohibited. Utilizing artificial intelligence and machine learning against IoT communication baselines that are usually very deterministic, we're able to build these conversation flows. And what you're seeing here is the flow genome screen, where we display all of the device's communications with both internal and external assets. You can imagine that if you had a security camera that constantly connected to the security camera server to display video or to upload video, if that camera was suddenly communicating with Russia, that would be something that would be flagged as suspicious. What you're seeing here is the constellation view of the network. Utilizing the constellation view, we can classify machines into common criteria, things like payment card systems or point of sale systems or medical devices, and then visualize their communications both through layer 2 and layer 3. Giving you this level of visibility around your device communications alongside the real-time asset inventory is an incredibly powerful tool, and of course brings a lot of security context along with it. As I mentioned before, the Ordr platform excels at creating and enforcing policies throughout the network. But we also can create automated policies that allows the real-time asset inventory system to be utilized in order so once a new device comes onto the network, a policy can automatically be applied to that device. You can imagine that if you're installing security cameras and you install one subsequent to a rolling out a policy for security cameras, that once that security camera is brought into the network and then classified with the Ordr system, an automated policy can be enforced in order to place that camera into the appropriate VLAN or subnet. And at Ordr, we actually utilize the existing enforcement points within your network, be it a firewall a wired switch, or a wireless access point. And as you can see here, we have a very diverse array of control points within the network where we can add a device to a deny list or an allow list, or block the port at the switch, or change a device's VLAN or subnet. Again, my name is Jeff Horne. I'm the Chief Security Officer here at Ordr, and I believe this starts our Q&A section.
Well, we do have the opportunity to take some questions now. A reminder, if you haven't submitted questions yet, you still can do so. Send them in via the chat window on your screen. We won't be able to get to all your questions, but for those that we don't answer today, again, we'll get responses back to you via email. That said, Jeff, first question I have for you. Why is IoT security so often overlooked?
Thank you, Tom. Yeah, one of the reasons why I think IoT security is often overlooked, really comes down to deployment. Really just technology moves so fast, and these devices have been pervasive because they're just seen as normal, innocuous devices. I think a good example of this are televisions. Televisions have been in almost every enterprise boardroom for the last 30 years. But over that time, TVs have gained internet capabilities, cameras that can record video, microphones that can always record audio, and they're essentially mini computers now running web services and even things like file transfer protocol services. So it's not only become pervasive, but it's really why they've been overlooked, is that they're being seen as innocuous devices and not mini computers that are running vulnerable services on a network.
My next question for you. What is the most damaging attack that affects IoT and unmanaged devices?
That's an interesting question. From the most damaging attack on IoT and unmanaged devices, I still have to go back to the Mirai botnet from several years ago. That botnet infected cameras, DVRs, routers, smart TVs, and we've seen a new variant within the last week here in July that increased the amount of capabilities for the Mirai botnet. And what I mean by that is that several exploits were packaged into a new variant of Mirai that allows it to infect even more unmanaged and IoT devices. And if you can remember, the Mirai botnet was responsible for one of the largest DDoSes that we've ever seen. So I still have to go back to Mirai as kind of the most damaging attack I've ever seen.
Very good, Jeff. I've got a third question for you. Question is, what can I do to mature my network segmentation?
I really like this question. So in terms of maturing network segregation, I think network segregation has historically been a function of IT, or at least a program that was run by IT. And not knocking IT at all, but they usually didn't have a lot of security awareness within those segmentation programs. And they saw segmentation as largely things like geographic regions. So if you can imagine where if you had multiple stores in multiple states inside the United States, you're obviously going to give each one of those stores its own network. But you can also think of this as a building where you have several floors, and there could be a VLAN per floor, and then a subnet for each individual business unit. So HR is on their own subnet and engineering is on their own. And I really think that security and the security team should be brought into the discussion. So device-centric security segregation is really what we need. We need to understand what these devices are, who they communicate to, and what are the inherent vulnerabilities inside of these unmanaged devices. Because like I said before, a lot of these are running either vulnerable operating systems or they have vulnerabilities that can just never be patched.
Now, Jeff, we've got time for one final question, if I may. Do you find that there's a preponderance of insecure or unnecessary network services on IoT devices that are exposing security risks?
Yeah, there are just so many completely insecure IoT devices. And the blame is really necessarily pointed at the device manufacturers themselves. The device manufacturers just simply haven't figured security out yet. I mean, it's a little frustrating when you are dealing with, IoT devices that have a hard-coded username and password that cannot be changed. I mean, I thought from a security perspective, this was, a practice that ended, 30 years ago, but, we're seeing it pop up in several of these IoT devices. Well, thank you so much for your questions. Please reach out to me if you have any more, and I'll try to answer them.
Well, very good, Jeff. Again, I want to thank you for your time, your insight, and especially for answering these questions. And I want to thank our attendees. You all took time out of your day to attend our webinar, and we're grateful for that. I do trust that today's discussion provided valuable new insight, new ideas to enable you and your organization to be even better prepared to tackle the security challenges we discussed here today. I look forward to seeing you again at one of our upcoming sessions. Until then, for Information Security Media Group, I'm Tom Field. Thank you so much.